So simply we can say a decorator is a function that receives another function and it adds some decoration, right? And then it returns against the new function. Because in algo trading, we need to know that which functions is taking how much time to execute, because that decides the profitability. Because in HFT, the game is all about the timing. So we have to make sure that our program is taking less time. So you can think that only the global namespace remains there. Otherwise, all the local namespaces, the function calls vanished as soon as the function execution finishes, right? So this is how it works. Welcome back to the day 19 of the 100 days of hell with Python algo trading. This will be the last topic of the core Python, and after that we'll start with absolutely interesting stuffs like Python libraries and much more. And today we'll be covering Python decorators, which is a little bit tough and complex, but I'll try my best to make you understand with so many easy examples. So without further ado, let's get started. Let's first understand what are the decorators. So a decorator in Python is a function that receives another function as input and adds some functionality, that is decoration, to it and returns it. So simply we can say a decorator is a function that receives another function and it adds some decoration, right? And then it returns against the new function. Simple. This can happen only because Python functions are first class citizens. So what are the first class citizens? Which can be stored as a variable, which can be passed as an argument, and which can be returned from a function, and even can be stored in a list, dictionaries, tuples. So those are the first class citizens, right? Similarly, this happens in decorators also because Python functions are first class citizens, right? So now let's see. There are two types of decorators available in Python. The first is built-in decorators like static method, class method, abstract method, and property, which we have already seen somewhere at many places. The second is user-defined decorators that we programmers can create according to our needs. Means the second is custom decorators. Now let's quickly understand the use cases of Python decorators in the algo trading. First, Python decorators can be used in logging. So automatically log function calls and the results, useful for monitoring and debugging trading operations, right? Because with the help of decorators, we can store or log the function calls, and it really helps in the monitoring and the debugging, right? If there is any error comes, we can quickly find out that what is the reason behind that and what functions is causing that error. The second is timing. So we can use the Python decorators to measure the execution time of any program. And again, it is important for ensuring the performance of trading algorithms, because in algo trading, we need to know that which functions is taking how much time to execute, because that decides the profitability, right? Because in HFT, the game is all about the timing. So we have to make sure that our program is taking less time, right? So we can use in logging and timing. The third is a retry mechanism. So automatically retry a function if it raises specific exceptions. So we can code that if it raises a specific exception, it will retry that function. Again, it is useful for handling intermittent network requests or database operations. So we can also code that for the intermittent network operations or for the database request, we can use this. The fourth is access control. So it enforces access controls based on user roles or permissions, ensures that only authorized users can perform certain actions. So we can have some conditions in the Python decorator functions so that it can only give access to those people who are authorized. So we can use this in access control. And the last but not the least is resource management. So ensure proper acquisition and release of resources like database connections or files, and helps manage resources efficiently and avoid leaks. So it will definitely help in the resource utilization, because we can monitor the performance with the help of decorators. It will definitely and efficiently help in the resource utilization, right? So these decorators help improve code maintainability, readability, and functionality in algorithmic trading system. So let me quickly show you roughly what are the decorators and what functions they perform. So let's say we have a function which provides the trade details. So I'll write trade details, right? And there can be any code. So that's not the concern here. And we have another function, and that we will be using as decorator. So what this function do, it will, let me give it the name, decorator. So what it will do, it will just add some functionality to this function, right? So what it will do, it will just, let's say, and sometimes we require some patterns, right? So let's say if it is printing out some trade details, so let's say it is printing out some dictionary, okay? Inside that, it is giving that the symbol is Apple, and let's say price, it is also giving, let's say 100. So means when we execute this function, it is printing out these details. But what we want that these details should be like printed in a good manner. So what we will do, we'll just ask this decorator function that please decorate my this function. So what it will do, it will just print some decoration. So let's say it is printing some stars here. Okay, then it will call this function. So here there will be a function call. So it can call trade details and the function call. And again, below these also it will print some stars so that it looks nice, simple. What will happen now? First, this will print the stars, right? So the stars will be printed out. And then the function call is happening, right? So when this call happens, it will print this. So this will be printed here, like let's say symbol and price. And again, it will print a star. So I'm sure that you have seen in so many program execution or while installing any program that there is a pattern. It can be a robot, it can be a man, a woman, any design, any star pattern or anything else. So that we can also apply with the help of decorators. So this is just a small example, but now we'll proceed with the real examples and I'll make you understand that how we can use this in the algo trading, right? So without a further ado, let's get started. Okay, let's define a function. So for example, we have function for SMS strategy. So strategy, and inside that we are passing some trade data, right? So it will be definitely a dynamic data. So I'll write trade data. What is happening here? First, let me define a trade data outside. So trade data, it can be a dictionary. So here the key, prices, and the value of key is a list. So let's say it is 10, 20, 30, 40, 50. Very simple, right? And inside that function, what can be the prices? It can be the trade data and the key, which is prices, right? And it will return the simple moving average. So what it will be? The sum of these prices, right? So what we can do, I can just write sum of the prices divide by length of the prices. As simple as that. So now if I go ahead and call this function SMS strategy and pass the trade data, I get 30. So that's a very simple function, correct? Let's suppose we have multiple strategies. Let's say we have around 1000 strategies and we want to have some kind of function which can decorate all these strategies. So we have two options. One option is to go and change all the functions of every strategy. Another option is to just create another function which can handle all those strategies. So what we will do now, I'll go ahead and create another function and let's say I can give it, so what it will do, it can modify any strategy. So modified strategy, and here what I'll do, I'll just pass any strategy. So let's say SMS strategy. So I'll give here the name of parameter. It can be, let's say, base strategy, right? It can be base strategy and the trade data, which is dynamic, right? So I can just write dynamic data, correct? And what it will do, for the sake of this example, I'll just print some stars and I'll say initializing modified strategy, and I'll copy and paste the same number of stars for the symmetry, correct? And again I can print another statement, let's say here, and we can give it name ending modified strategy, correct? And between these we can call this function, right? So we have passed this function as a base strategy here. So I'll write base strategy and the dynamic data. I'll just remove this function call for now. I'll just comment it out, and now what we'll do, we'll be calling this function, right? So modified strategy, and inside that we'll pass the SMS strategy and the trade data, correct? So when we hit shift enter, it is printing out both the values, but not this one. So for that we have to print this. So I'll just write print. When we hit shift enter, it gives us the 30. So now what is the benefit of this? That we can keep this same and we can have another like 1000 strategies like this, and this can be used for every strategy. Let's say I'll quickly go ahead and create another strategy, and it could be like, let's say Bollinger Band, so BB strategy, just for the example. It is also returning same thing, so I'll just change the values here to right. So now what I can do, I can just call, instead of SMS strategy, I'll just call BB strategy, and it will give me 300. So that is the flexibility of these decorators and the usefulness of these decorators, right? So now let's create another example which can be really used somewhere. So what we will do, I'll just copy and paste this whole here, and I'll just remove this from, and I'll just change this modify strategy. So I'll write here the function name as calculate execution time, correct? And it can be same initializing modified strategy, and here we can print the starting time. So for that, module import date time from date time import date time, and what we can do here, we can print the starting time, right? So in that way, so can be date time dot now, right? And similarly, after the program has finished, we can also print that time also here, right? So date time, and here the formatted string. So now I guess we are good to go, because it will print before the function call and after the function call. And so now what we can do, we can simply call this function. So instead of modified strategy, we have to now call this calculate execution time, and when we hit shift enter, so now you can see that we have the starting time and the end time. Here actually the time difference is very, very less, because a very small program. So for that you can have like a bigger value, right? So for that, what you will do, go to this BB strategy, and here you can import time also, and for that you can make it sleep. So time dot sleep, and let's say give it 5 seconds. So now when you hit shift enter, it will start at 6:24:19, and then you will be having 6:24 and 24. So means it slept for 5 seconds, and you can calculate the starting time and the end time. So that is very useful really in the algo trading. Just practice few questions, you will realize that how useful this is, right? Now what we can do, we can also run this in the Python tutor. So let's go there and check, because here visualization is very important. You should be having a clear picture in your mind that what is happening here. So I'll just copy and paste this to the Python tutor. Okay, we have the Python tutor here, and so let's click on the visualize execution. It says time not found or not supported. I guess they have blocked this feature because it might hang their website. So what we will do, we'll just remove this from the code for now. Now we click on visualize execution. Now let's click on the next, and we have a global namespace. It will skip the whole function, and it will go to the next variable create data, and now it will go again to the next function. It will skip all the function, and now we have a function call, right? And you can see now that in the global namespace, we have date time, BB strategy, trade data, calculate execution time. These all are the global namespace keys, correct? And this one is the local namespace of the calculate execution time function. So now when we click on next, it will print the initializing modified strategy, correct? And also the time. You can see here. Now it will go to this BB strategy, and you can see here BB strategy and trade data and the value of the dictionary here. Again, next, the function execution will happen here. Next, and it will return 300, right? So it will print out that here. And next, again, the ending modified strategy. So it will print out that execution time, the end time. And so you can think that only the global namespace remains there. Otherwise, all the local namespaces, the function calls vanished as soon as the function execution finishes, right? So this is how it works. Let me again open the Visual Studio Code, proceed with the further examples. So here we can see that this function was working as a decorator, but what if we can simplify this? Because it is a little bit complex process, right? We have to call the function, then again we have to pass the function here, the variable here. So let me make it a little bit simpler. What I'll do here, so I'll create another function inside this and I'll give it a name wrapper. And generally in decorators, the name is wrapper only. So wrapper, and here this dynamic data can be passed here, and this can be inside this wrapper, and this function will now return this wrapper. So return wrapper. Let's not remove this. I'll just comment it out. So now what is happening? We have decorator function and we have a base function. This will be the strategy. Like it can be variable. When we have multiple strategies, we can have anything here, but this will be fixed, right? So instead of calling this function like this, what we will do, I'll just go here and add @ and the name of the function. So it is calculate execution time, and that's it. So when I hit shift enter, okay, now we are getting the error. So actually what is happening here, we have defined this decorator function here. So we have to write this. Now what we will do, we'll just call this BB strategy and trade data, this function, and it will work like a charm. You can see here, it will just wait for 5 seconds and it will print out that. So this is how we can use decorator, and you have seen that whenever we want to make any function decorator, we have to add the @ and that's it. So like you can create here multiple functions and you can use all those functions with this decorator. So let's try another example. Let's say we have this, instead of BB, we have mean reversion, just the name, and here I'll change the values to 1000, 2000, 3000, 4000 and 5000, correct? And I'll simply call this function here, and when I hit shift enter, it will wait for 5 seconds, the sleep time, and it will give us the results 3000, right? So hope you are able to understand what I'm trying to say. And this is really very simple, and just have to focus a little bit and you are good to go, correct? Okay, now let's create a function which can be really used in real life situation. So I'll create a function with the name calculate PNL, correct? And what it will receive in parameters, it will receive profit, and it will simply print that. So print and a formatted string, and here it can be, let's say, profit, and here it will be the profit, correct? Similarly, we have another function define, and it will log trades, right? So log trade, so it will receive a symbol here, and similarly it will also print out the symbol name. So symbol SYM, symbol, correct? So now we should be having a decorator which handles these functions. Now we want to check that we should be having a function which can check whether this is a float or not. So if the parameter is not float, it will raise an error. And similarly in this function, if the parameter is not string, it will raise an error. So what we can do, let's say we have a function with the name sanity check, right? And we are passing a float here, a float, correct? And here also the same decorator, but here we are passing the sanity check and str. Like you can also create this function first, but for better understanding, what we can do, we can just give it the name here, and we know that when we call this function, we are also passing this float as an argument here, right? And similarly in here it is string. So what we will do now let's create the sanity check. So what we'll do, I'll create sanity check function, and here what we will receive, we will receive the data type, right? So data type, and then we have to create a function, the outer function. So define outer wrapper, and it will receive the function name, right? The func name, and inside that we have another wrapper which can be inner wrapper, and it will receive the args, correct? Because it can be multiple arguments, so that's why this. And now we check if is instance. Why? Because we are expecting that data type float or string here, and the argument should be the subclass of that. And if you remember, we have already studied this is instance previously. So if you have any doubt, let me know in the comments. Definitely we can again understand in the next classes. So what I'll do here, I'll write args, and is means here args is the subclass of this data type or not, right? If it is true, then what it will do, it will return the func name, and inside that it will return the data type. Simple. If not, else it will raise print an error. Let's say we can give it the name type error. You can say data type not correct. We can also use the error handling here, no problem. Now what will happen, we'll just return the inner wrapper, and again here also return the outer wrapper. Correct? So one more thing, you need to make sure that you have to define this before this. So I can write it here, and we can write these functions here, right? So when you hit shift enter, it works fine. It will not throw any error. So now what you can do, you can simply call this function. So calculate profit, and here let's give 256. Okay, now we are getting this profit class float. So actually we have made some mistake here, and the mistake was this. So actually we need to return the args, right? So okay, now when we hit shift enter, we get the profit as 256. But let's say if I just pass here a string 256, it will throw an error that data type is not correct. Similarly, for this log trade, what we can do, I can just call log trade, and inside that I can pass a symbol, let's say BTC, and when I hit shift enter, it will return okay, I need to change this. Yeah, it will return a symbol, but if I just pass any other, let's say 200, it will throw an error that data type is not correct. So that's how it works, and it's really very easy. Please practice the multiple choice questions, the task questions, and perform the mini project. It will definitely help you. So with that being said, this is it for the day, and we are done with all the topics of core Python very extensively, and we have covered almost everything in detail. And I think now you should be able to perform any Python program. After that, from tomorrow onwards, I will be proceeding with the Python libraries, and let me know if you want that how we can proceed. If you have any suggestions, you can let me know. And otherwise, I'll post the whole syllabus this weekend for sure. Then you can plan your studies accordingly. So yeah, that's it for now, and we'll see you in the next video. Until then, bye bye, take care, have a nice day.